remote access Trojans are commonly used tools in cybersecurity for both legitimate purposes and by malicious actors. So, remote access Trojans enable remote control and management of a computer system, allowing a user to perform actions on a remote machine through the network connection. So, while some remote access Trojans like TeamViewer are widely used for legitimate purposes, others are specifically designed to be stealthy and hard to detect, and making them attractive to hackers. So, remote access Trojans consist of two components: a client program that runs on the victim's machine and a server program that runs on the attacker's machine. So these components work together to establish a network connection and enable remote control. So there are two main configurations in which remote access Trojans operate, depending on who initiates the communications, which is forward connections and reverse connections. So let's get started by learning about forward connections. So in forward connection setup, the attacker initiates the connection with the victim's machine. So the attacker server program actively connects to the client program running on the victim's computer. So this configuration is useful when the attacker knows the victim's IP address or has some access to a network infrastructure that allows them to reach the victim's machine directly. And we also have the reverse connections. So in a reverse connection setup, the victim's machine creates a connection to the attacker's machine, and the client program running on the victim's computer establishes the connection with the attacker's server program. So this configuration is often preferred by attackers because it bypasses firewall restrictions and allows them to gain access to systems behind network boundaries or with dynamic addresses. So both forward and reverse connection remote access Trojans provide attackers with a range of capabilities to control the victim's computer remotely. So once the connection is established, the attacker can perform actions including but not limited to file management, like manipulating files and directories on the victim's machine, such as uploading, downloading, modifying, or deleting files. And system control, executing commands or running scripts on the victim's computer, enabling actions like launching applications, manipulating settings, or restarting the computer. Surveillance, monitoring the victim's screen, capturing keystrokes, or accessing the webcam and microphone for covert surveillance. And data theft, so stealing sensitive information such as login credentials, personal documents, or financial data stored on the victim's machine. And also botnet creation, transforming the compromised machine into a part of botnet, which is a network of infected computers used for coordinated cyber attacks. So for remote access Trojan purposes, we will use socket programming in Python. So before learning about malware development, it is necessary to learn about the network programming in Python and how we can create a network application. So the first step in learning network programming is to learn about what we call sockets. Sockets here. You can also write it on the screen like that. Sockets. Oops. Sockets. Sockets here. So, sockets provide a fundamental mechanism for creating network-based applications, and our malware is going to be essentially a network application, right? So let's start by understanding the sockets first. So before we jump into socket programming, let's understand what sockets is and how it can be used to develop network-based applications. So a socket is one endpoint of two-way communication link between two programs running on the network here. So this is the sockets, for example, and this is the communication, like. So it's actually, it might be sound like something more basic, but it has, it's getting more complicated when we deep dive into it. So a socket is bound to port number so that the TCP layer can identify the application that data is destined to be sent to. For example, for every socket, we need some port number. So this is IP and port, right? Port. And sockets are generally used in client-server communication, where one node is a client here, client, and the another node is server, and that's responding to that call here or connection, right? So at the each end of the connection, each process, such as network initiation program or a network responding program, will employ a socket. So a socket is typically identified by an IP address concatenated with a port number like this. In typical scenario, a server usually listens on a certain port for incoming connection requests from clients, and once client request arrives, the server accepts the request and initiates the socket connection with the client. So servers implementing specific services here, such as HTTP or HTTPS or like Telnet, FTP, and so on. So they listen on popular, known and well-known ports such as 80, 21, and 443. And keep in mind that ports from 1 to 1024 are regarded as well-known ports and should not be used in implementing on your own programs, as they already reserved. So in some ports you might use this in some programs, but in somehow they will be used for some programs and your connection will be failed somehow. So and let's try to understand how sockets work in Python here. Now we will import socket. So to create a socket in Python, we utilize a socket library. So this library is a part of Python's standard package. This is a part of Python's standard package, so we don't need to install anything. So now let's take a look at the application programming interface of this module. So an API is a software interface to code base that lets you access functionality of the code with some level of abstraction. So we have this socket here, for example, socket.socket here. So this socket here, application program interface, helps us to create a socket object. So we can make use of this function called this, so to create a socket, right? So let's take a look at the parameters of this method. So to see what parameters are available in the function, we can use Control and P to see it briefly here. And as you can see here, it gets family, address family, socket kind, port, and file now here. We can also open this here with here, generate folder, go to declaration or usages here. And as you can see here, we are seeing family type proto and file now here. This is the function here, how it's written. And here you can also use the docs documents to learn more about the socket function. And here, as you can see here, we are seeing that, oops, not here. So here we are seeing a socket in a class, and its constructor requires family type proto and file no parameters. In this case, it's not actually using. And as you can see here, we have a commands here and docs. So for now, you just need to understand that calling the constructor of the socket here calls calling the constructor of the socket calls return a socket object that can be used to communicate with other devices. And we also have socket.bind here. So also let's take a deep look at this again. We'll go to implementations, and here implement a type declaration. Here we can also go to type no, we will go to declaration or usages or implementation. I'm sorry. Cannot find declaration here. So that's because cannot find the reference bind socket pair here. So create a functional model. So here, after you created this socket object here, for example, socket or my socket, and after that, after creation of the socket, we will do my socket.bind here. So this function here lets us implementations, and as you can see, this bind here. So to create a server, you need to bind a socket to the IP address and the port that the socket will utilize for communication. And also keep in mind that this function is only used when creating a server program. So for servers, these must be explicitly assigned, since the server has to listen for incoming connections on a specified port. So in the case of a client, the IP and port are automatically assigned, so you will not use this function on a client application, but you will need that in server application. And we also have the listen here, listen function. So this listen function is used by servers to listen for any incoming connection as per the configuration assigned this bind here. So my socket.bind method. So in other words, it waits for any connection attempt to the specified IP on the specified port, and this requires a queue size for the number of connections to be held in quote here. And as you can see, we are only going the backlog one integer here. So here this means allow 213 connections at a time. In most cases, you can use also, depends on the project actually, you can also use 1000 connections at a time or 5 connections at a time. So it depends on the project, right? And we also have the accept. So as the name indicates, this my socket accept. So socket accept here accept connections made by clients. So this is actually a blocking function call, so which means that the program execution will pause here until the connection is successfully made. So once a connection is made, the execution program will continue. And we also have the mySocket.connect here. So as you remember from the accept, this is also block execution until the clients connect. So the question now arises, how do clients connect? So there's a connect comes into play. This method initiates a connection to the server, and if a server is waiting for incoming connections, communication will follow. So when a call to socket connect happens, socket accept gets unblocked in the server and execution of the program continues. So don't worry if this all seems very confusing to you at the moment as to which functions are called in the server and which functions in the clients, but you will get a clear idea of this when we build examples here. And we just need to also consider 3 parameters as well, which we will use in next project of ours. Then one of which the socket.send. So once the connection is made by between the server and clients, the most important part of the program comes, which is to send data over these connections. So this is where most of the user-defined logic will reside here. So the socket send method is used to send bytes over the network. So and keep in mind that the input to this function is bytes. So any data, as you can see, it's bytes, right? So any data you want to send over this connection should be in the form of bytes. So, which is not a hard thing to convert from bytes to strings or from files to bytes. So it's actually easy, not like sounds like you might confuse it from first, but and like I will be honest, because like 5 or 6 years ago when I started working on these sockets, like damn, how we will send and receive bytes over the network, but we can't read the bytes. But don't worry about it, because Python has libraries and functions to turn bytes onto like meaningful messages or meaningful messages to bytes, so don't worry about it. And we also have this socket, my socket. Of course we have this send, and we will also need to have receive. So this method, as the name suggests, is used to receive bytes once the user sends the data. So also keep in mind that every call to the send or receive methods should be handled properly. For example, if the server is sending data, the client should be ready to receive this data, and vice versa. So the input to this method is the number of bytes you want to receive at once here, and bytes here. So this is the buffer. This is the buffer created by the program to temporarily store data, and once a certain memory of bytes arrive, they can be read, and the buffer is ready for the next cycle. And lastly, I know this lecture actually might be quite long for now, but this is the last method here that we're gonna use here, which is the close. So once you have done everything you wanted to do with a program, you must close the socket so that the port can become available to other programs to be used. So also keep in mind that even if you don't close the socket properly, it will be released by your operating system after a period of time once your program exists or computer restarts. So however, it is always a good idea to close the sockets manually inside the program. So if the program exists and the socket is not closed properly, any incoming request may be blocked, or the operating system may refuse to use the socket for the next program because it may think that the port is still in use.